Hey guys, welcome to mathspays.com. Today we're looking at linear simultaneous equations with a focus on substitution. This is part 1 of a part 2 series. First of all, make sure you have seen the linear equations episodes, okay? Because certainly there are 3 different things happening today. We're first of all looking at what is a linear equation. Hopefully you know that answer. 2, we're looking at what is a simultaneous equation. And 3, we're looking at what is the substitution method, because there is more than one method to solve a simultaneous equation. Okay, so first of all, you've looked at questions like this. Solve x plus 3 equals 4. And hopefully by now you'll notice that's a really easy equation because you simply subtract the 3 and we get x is equal to 1. But what makes it a linear equation? Well, hopefully you remember, because the highest power is a 1, x to the power of 1, that is a linear. Okay, you might remember that linear graphs are straight line graphs. For example, something like y equals x plus 2, okay, is a linear equation because the x has the highest power as a 1. So that's what a linear equation is. Okay, number 2, what does simultaneous mean? Well, let's look at this little graph over here, because of course that's a linear graph. Y equals x plus 2. Now, what a simultaneous equation is, well, first of all, it looks that we want to solve an equation that has 2 unknowns, okay, 2 variables. But the problem is, at this particular point, well, I wonder if you can see the problem. If I said to you, go and solve this equation, what would be the major kind of issues that you might have with this question? Well, let's have a look at some possible solutions. For example, what if x equaled 6? So y equals 6. What would x equal? Well, in this case, x must equal 4, okay, because we've got 4 plus 2 makes 6. But what if, let's say, y equaled 10? Well, in this case, x would have to equal 8, because 8 plus 2 equals 10. Okay, which means that you're going to have different possible values for x and y. In fact, there would be infinite amount, because you could have negative numbers, you could have decimal numbers, you could have really big numbers, like you could have 100 equals 98 plus 2, so x equals 98, y equals 100. You've got so many different possible solutions. How can I solve for just getting one nice answer? You're not going to be able to do it. So what simultaneous means, it means that we look not just at one graph, but we look at a second graph. For example, x plus y equals, let's say, I don't know, 6. Okay, and that graph, now, if you might remember how to rearrange it and make it y equals negative x plus 6, what you might find is that graph looks like this. Okay, it's a negative graph. And what a simultaneous equation does, it looks at these two graphs and it finds a common solution. Okay, a common solution, or let's say, also we know that as a coordinate. Okay, and that coordinate we often refer to as xy, and look what's in both of these equations. We have x's and y's. Okay, so a simultaneous equation means that we've got 2 different equations and we solve them simultaneously because they have the same y value and the same x value, and that means that there will be one solution for both of those. So then brings to me point 3. What does substitution mean? Well, hopefully by now we know that substitution means to replace. Okay, we replace often letters with numbers or vice versa. So I'm going to rewrite these 2 equations. We've got the x plus y equals 6, and we've got the y is equal to x plus 2. So what we're going to be looking at is that we're going to be substituting this y value for the x plus 2. Now, why do we do that? Well, because it says here y is equal to x plus 2, which means those 2 things are exactly the same. So if I replace that, I'm going to put it in brackets so you can clearly see what I've replaced the y with. What you might notice now is that there's no longer a y value, which means we can just find a normal linear equation solution. Now, that's kind of like a 1 in front of that bracket, so 1 times x is x and 1 times 2 is 2. The brackets don't have a whole lot of meaning in this particular case because when I expand it out, we still get the same number. Of course, if there was a 2 there, it would make a big difference. But I'm going to solve that. We get 2x plus 2 equals 6. I'm going to subtract the 2 across. We get 2x is equal to 4. I'm going to subtract the 2 across. Okay, so divide the 2 across, and we get 4 divided by 2 equals 2. So we've got a nice solution for x equals 2, which means that coordinate there would have an x coordinate of 2. Now, the beautiful thing about simultaneous equations is that it doesn't actually matter which of these two equations, the x plus y equals 6 or the y equals x plus 2, that I substitute both into, because it is a solution for both. Which means if I put into the top one, look what happens. We've got 2 plus y equals 6. I'm going to subtract the 2 across. I get y equals 4. If I put it into the bottom equation, y equals 2 plus 2, y equals 4. Look at that, the solutions are exactly the same, which means this coordinate is the coordinate 2, 4, and that looks quite accurate, doesn't it? If that's a 4 and that's a 2 there, we've got our solutions. And often we would write it as a solution as our 2, 4, and that shows a nice x and y coordinate. Okay, so that is your first simultaneous equation or linear simultaneous equation solved by substitution. Usually substitution is much easier when we have y is equal to something, or it might be x is equal to something, so we can chuck it back in. Occasionally you might see some more challenging questions later on where you can rearrange it, but we have another method for that. Okay, like all my lessons, guys, I do encourage you to pause and have a crack and then see how you end up. So let's see how you go with this particular question here. All right, welcome back. How'd you go? First of all, we've got y is equal to x plus 6. So I'm going to substitute that y value for the x plus 6. So x plus, I'm going to chuck in the x plus 6 equals 8. I can clearly see now what's been substituted into it. Now, of course, if it's only one y, you don't really need to have the brackets, but of course, if you had two y's, you'd have two lots of everything that's going on in here. But in this case, we've just got x plus 6 equals 8. Again, you might not even write the brackets in the first line. You can just write the second line straight away. But we get 2x plus 6 equals 8. I'm going to solve it like a normal two-step equation. 2x equals 2. And in this case, x is equal to 1. That's a nice little solution there. I'm going to now put it back into, now the second solution is probably, or second equation is much easier because y is the subject. So I don't have to do any rearranging. So y equals 1 plus 6, y is equal to 7. Therefore, I have my solution of 1, 7. Okay, my coordinate. Now, if you use the first coordinate, you could have, so the first equation, you could still have done that. 1 plus y equals 8. Subtract the 1. Look at that, y is 7. It still hasn't changed. I've got a nice solution there. Okay, so that's a pretty straightforward linear simultaneous equation. But again, because I had the y is equal to, that's why substitution was nice and easy, because I could just replace it. Okay, I've got a more challenging one now for you. Okay, this is slightly more difficult. I wonder if you notice why. I want you to have a crack at it. Okay, just by face value, what you might recognize is that it's no longer just x plus y. I've got 3x plus 4y. I've got this more challenging equation for y. Okay, there's a lot more going on. Pause it, see how you go, and we'll come back to you. All right, welcome back, guys. So we've got these two equations here. I've got y is equal to 2x minus 1, which means I'm going to be replacing this y here. Okay, I'm going to rewrite that out so we can see it nice and easily. Okay, so I'm going to be replacing that y value there with the 2x minus 1 because it says that y is equal to that. So just like that last question, I'm going to rewrite it and have 3x plus 4 lots of y. In this case, y is 2x minus 1, and that equals 29. So see, because I've got a number in front of the brackets are really important. They're significant because we know that when we have brackets, we must multiply. 4 times 2 is 8x, 4 times negative 1 is negative 4. And that's pretty much only the more challenging step. I now can simplify the x's. 11x take away 4 equals 29. I'm going to add the 4 across here to make 11x is equal to 33. I'm going to divide by the 11 to make x is equal to 3. It turned out to be a fairly nice solution. It won't always happen that way. Now, I've got another choice of putting into one of these two equations. Because that's y is equal to, y is the subject, that's so much easier to put it back into. So I've got y is equal to 2 lots of 3, and then take away 1. You might want to put brackets in there, it's up to you, and then you can put it into your calculator or do it in your head. 2 times 3 is 6, 6 take away 1 equals 5. I now have my solution of 3, 5, and that is my simultaneous equation. You could have put it into the second equation here, of course, but look how much more challenging it is. You got 3 times 3 plus 4y equals 29, which means that's 9 plus 4y equals 29. I'm going to take the 9 across. We get 4y equals 20. Divide the 4 across. I get y is equal to 5. And it is exactly the same solution, as you can see. But how much more challenging was that second way? Okay, because it was much easier than y was the subject. Look, guys, I'm going to leave it there. Have a crack at your textbook work. That is our linear simultaneous equations via substitution. Once you feel relatively confident with this, then you can move on to the elimination method, which again is another style, another setup of simultaneous equations. Some say, might be a little bit more challenging. I think it's easier, but we'll see how we get on. Have a great day, guys. That's linear simultaneous equations substitution.